to learn some math. Learn some math.
Next up is the surface area of cones. This is our last one in a way that we're going to talk about for surface area for a little bit. But your learning target is I can find the surface area of cones. Let's get going with it. So first thing we're going to do is we're going to do a few definitions, and the first thing we're going to define is the vertex of a cone. Okay, vertex of a cone. That's the point where the surface comes to a single point. Okay, so the vertex in this diagram here is right at the very top of this cone. Okay, now the axis of a cone is the segment. The axis of the cone is the segment that connects the vertex, okay, that point that we just talked about, of the cone to the center of the circular base. Okay, it goes right down to the center. All right. Now, when we have a right cone, like this shape right here, the segment is perpendicular to the base. When we have an oblique cone like this one, it's kind of off-kiltered. It's not perpendicular. All right. Now, the slant height of a right cone, okay, we're just talking about a right cone now, is the distance from the vertex up here to the point lying on the edge of the base. Okay, it could be any single point around the entire thing, but the slant height will stay consistent for a right cone. Okay, it's going to be the exact same around the entire shape. Now there's a few formulas that go along with this. Again, just like we've been doing, there's the lateral area. Okay, lateral area meaning we're talking about that surface, the lateral surface of a right cone is equal to pi times the radius times the slant height. Okay, so what that looks like is just lateral area is equal to pi r times L. Okay, all of those are just going to be multiplied together. Now the surface area, if we break this shape out, it's going to look something like this. The surface area of a right cone is equal to the lateral area, which remember is pi times r times L, plus the base area. Okay, not 2 times the base area, just the base area, because there's only one base. We could rewrite this a different way as L, meaning our lateral area, plus our base area B. Okay, that's all we have to do for that. Alright, so example 1 wants us to find the lateral area and surface area of each figure. We need to round our answers to the nearest hundredth if necessary, and we can leave our answers in terms of pi for all answers that contain pi, which is kind of nice, right? So first let's go here and like any of these surface areas, the first thing we need to find is the lateral area. And remember, lateral area was equal to pi times the radius times the slant height, L. Okay? So let's go ahead and fill that information in. What we know about the this whole thing here is that the radius is equal to, well, this whole thing measures the diameter, and that's 24 miles, so our radius would be half of that, which means we're going to be talking about a radius of 12, times the slant height, which is the distance from the vertex to a point on the base. That's 26.8 miles. And then all we have to do there is just multiply this out. And remember, we can leave this in terms of pi. So we're going to end up getting our lateral area to be pi times 12 times 26.8. Okay, so we're going to do 12 times 26.8. We end up getting 321.6. So our lateral area is 321.6 pi miles squared. Okay, that's going to be our lateral area. So that's the very first step. Now we have to figure out what our surface area is. Okay, and again, the surface area is just the lateral area plus the base area. All right. Now surface area we've already figured out the lateral area. That was 321.6 pi. And we just need to add that to the base area. And remember, the area of a circle is pi r squared. So we have to just add that to pi times our radius of 12 squared, which 12 squared is 144. And so this is going to look like 321.6 pi plus 144 pi. And then it's just the matter of adding all of this up together, and we end up getting, we're going to have 0.6 pi. 4 plus 1 is 5. 4 plus 2 is 6. 1 plus 3 is 4. So our area, our surface area of this cone is 465.6 pi. And that's all we have to do. Example 2 is much like the first one. We just have this written in words now instead of actually pictures. Okay. Again, you can draw a picture of this if you need to, but it's essentially the information is given to us, and all we have to do is transfer that to our equation. Remember, we always start with our lateral area, which is pi times our radius times the slant height. And we're told that we have a cone with a radius of 10 yards and a slant height of 22.4. So we just have to plug that information into our little formula here. We've got pi times our radius is 10 yards, times our slant height, which is 22.4. Okay. Now, what you need to remember is when you multiply by tens, you're only just moving the decimal point over, right? So really, we're just going to move that decimal point over 1, and we're going to end up getting our lateral area to be 224 pi. Okay, that's the lateral area. That means that's the area around the shape, not including that base, just around the shape. So next, we got to find our surface area still. That's just our lateral area plus our base area. So substitute this information in. We get our lateral area is 224 pi. Plus our base area, which remember area of a circle, because our base is in the shape of a circle, is in the form pi times radius squared. So pi times 10 squared. And 10 squared is obviously 100. So we have 100 pi plus our 224 pi, which leaves us, at the very end of this, when we add all this together, we're going to end up getting 324 pi. Alright, so our lateral area ended up being 224 pi. Our surface area ended up being 324 pi.
Stay in school. Math is fun.